The Van Allen belts are two layers of charged particles, primarily electrons and protons, that are trapped by Earth's magnetic field. Named after the American scientist James Van Allen, who discovered them in 1958, these belts protect Earth from harmful solar and cosmic radiation by deflecting or capturing charged particles before they can reach the planet's surface. The belts are essential to life on Earth, as they play a key role in shielding the atmosphere and, in turn, the planet from high-energy particles that could disrupt ecosystems and human health. There are generally two main Van Allen belts, the inner belt and the outer belt. The inner belt is closer to Earth, starting at about 1,000 kilometers, 620 miles, above the surface and extending up to around 12,000 kilometers, 7,500 miles. It primarily consists of high-energy protons. The outer belt begins around 13,000 kilometers, 8,100 miles, and extends up to about 60,000 kilometers, 37,000 miles. This belt contains a mix of electrons and protons, though electrons dominate. Between these two belts lies a relatively empty region known as the slot region, where particle density is lower. The intensity and shape of the belts can fluctuate in response to solar activity, such as solar flares and coronal mass ejections, which send waves of charged particles and radiation towards Earth. The belts form due to the interaction between Earth's magnetic field and charged particles originating from the Sun, the solar wind, as well as particles from cosmic rays. As charged particles approach Earth, they are caught by the magnetic field and spiral along its lines of force. The Earth's magnetic field lines converge at the poles, so particles are trapped in these looping paths, creating two main zones of high particle density, which we observe as the Van Allen belts. When particles within the belts collide with atoms in Earth's upper atmosphere, they produce phenomena such as the auroras, northern and southern lights, near the polar regions. During these events, particles within the belts are pushed further towards Earth's magnetic poles, where they interact with atmospheric gases and release light. The Van Allen belts are crucial for protecting life on Earth from radiation by blocking or absorbing much of the harmful charged particles emitted by the Sun and cosmic sources. Without these belts, Earth would be more exposed to high-energy radiation, which could lead to significant health risks, technology malfunctions, and even atmospheric erosion over time. However, the belts also pose a hazard for spacecraft and astronauts. The high levels of radiation within the belts can damage electronic equipment and increase the risk of radiation exposure for astronauts. This was a particular challenge for the Apollo missions in the 1960s, as astronauts had to pass through the belts to reach the moon. Spacecraft engineers designed short-duration, low-exposure routes through the belts, minimizing the time astronauts spent in the radiation zones. Modern satellites and space missions are also carefully designed to either avoid the Van Allen belts or shield sensitive electronics from their radiation. Recent studies, including data from NASA's Van Allen probes launched in 2012, have helped scientists learn more about the dynamics and variations in the belts. These probes discovered a temporary third belt, which forms in response to specific solar events. They also provided new insights into how particles in the belts accelerate and move, improving our understanding of space weather and its potential impacts on Earth. In summary, the Van Allen belts are a protective layer of charged particles that play a vital role in shielding Earth from harmful solar and cosmic radiation. Their discovery was instrumental in understanding Earth's magnetic environment, and ongoing research continues to uncover the complexities of these fascinating regions of near-Earth space. Thank you for watching. We have some amazing videos coming up, so stay tuned and make sure to hit the subscribe button.